So today you will learn chapter 3, last subtopic for chapter 3, numerical methods, which is numerical solution of partial differential equation. So before this, okay, last week, you have learned about numerical solution of ODE. So remember, ordinary differential equation, we have one independent variable. So for partial differential equation, we have more than one independent variable. So we have two parts for this topic. The first one is classification of second order partial differential equation, which parabolic, hyperbolic and elliptic. And then you will learn about finite difference method. And you will learn just for parabolic problem. Okay. So let's look at what is partial differential equation. Okay, this partial differential equation is applied in fluid dynamics, elasticity, heat transfer, electromagnetic theory and others. Okay, apa maksud dia ni? Maksudnya this partial differential equation is represented in this field. For example, heat transfer. Okay, heat transfer, we can determine heat by using this equation, by using partial differential equation. Okay, so PDE is equation that contains one or more partial derivative of an unknown function that depends on at least two independent variables. Okay, this is example of partial differential equation. Let's say U is the unknown function. U depends at least two independent variable. Okay, for example, U depends on X and also T. So U is the unknown function. Okay, so the equation contain U. Okay, contain U and also the independent variable. U depends on X and also U depends on T. Okay, how to write PDE? So you can write like this, the form of del U over del T. So del U over del T, you can write it like this, UX. So del U over del Y, you can write it as UY. Okay, what if you have U, del square U over del X square? So you can write it as UXX. If del square U over del X del Y, you can write it as UXY. And what is order of PDE? Okay, U is the unknown function. So its derivative is del U over del X or del U over del T or del square U over del X square or del square U over del T square and so on. So this is the derivative of U. Derivatives of U. So we look at the order of PDE by the highest order of derivative. So for this example, the derivative is del U over del X. Okay, order dia satu, dia kuasa satu. So this is first order PDE. Okay, for this example, we have two derivatives, del U over del T and del square U over del X square. But the highest order is 2. So this is second order PDE. Okay, what about linear and non-linear PDE? Okay, linear PDE. Okay, when the unknown function U, this U, where's our U? Okay, this U and its derivative only power 1. And this U can multiply with its derivative. So for linear, look at this example. So we have UT and also U. Okay, UT and U power 1. If you have u square, then it is nonlinear. Okay, this one, for this example, it is nonlinear because u multiply with its derivative. So this equation is nonlinear PDE. Then we move to how to classify linear second order partial differential equation. Okay, this is the general form of linear second order PDE in two independent variables x and y. So this is the general form. We have a multiply with del square u over del x square. So remember, a is the coefficient of del square u over del x square. Susunan dia mesti macam ni. We have del square u over del x square first, and then followed by del square u over del x del y, and then followed by del square u over del y square, and the rest. Okay, the most important is these three, A, B, and C. Okay, let's say we have u in terms of x and t. So the general solution will be A u xx plus B u xt plus C u tt plus and the rest. So to classify the type of PDE, okay, we have three types of PDE: parabolic, hyperbolic, and elliptic. So why must classify the equation? Okay, this because for different type of PDE, we have different type of solution, different type of method to solve the equation. That's why you must classify first. Okay, to classify, we will use this formula: b square minus 4ac. This b, a, and c is from the general form. A is the coefficient for x square. Okay, B coefficient for del square u over del xy. C is the coefficient for del square u over del y square. So for parabolic equation, the equation is parabolic if b square minus 4ac equal to 0. Okay, after you determine A, B, and C from the equation, then you substitute in this formula. Okay, when you get this one equal to 0, then the equation is parabolic. If greater than 0, for example, you get 4, then the equation is, this equation, or this equation is hyperbolic. That if if you substitute, you get less than 0, then the equation is elliptic. Okay, sometimes it can be for same equation, you can have these three types, okay, mixed type. It depends on the equation. Okay, let's look at example. Okay, let's classify the following equation as hyperbolic, parabolic, or elliptic. Look at the, example 1. Okay, the first step is to write the equation in general form. Make sure the first term is uxx. Okay, follow this general form: uxx, uxy, and uyy. So we have uxx, uxy, and also uyy. And then determine A, B, and also C. So A is the coefficient for uxx. A equal to 1. B equal to, this is B. A, B, C. So B equal to 2, C equal to 3. And then substitute in the formula. B square minus 4AC equal to 2 square minus 4. A is 1, C is 3. And then calculate the value. You will get Negative 8. Okay, since negative 8 is less than 0, then, okay, hence, the equation is, apa dia? Less than 0 is elliptic. Elliptic. Okay, let's look at example 2. Okay, sama juga. You must make sure the equation is in the general form. So uxx. So this is A. B is for x and t. B. And then this is C. And substitute into B square minus 4AC. B square. Okay. So B, don't forget the minus here. B is minus 5 square minus 4. A is 2. C is negative 4. Okay, when you calculate, you will get 57. Okay, which is greater than 0. So the equation is hyperbolic. Okay, next. So we have uxx, only uxx. So A equal to 1, B equal to 0, C equal to 0. Then substitute B square minus 4AC. Look at 0 minus 4, 1, 0. Okay, which is 0. So the equation is parabolic. Okay, what if you get, okay, after you substitute for this equation 4, we have A equal to Y, B equal to 0, C equal to Y. And then when you substitute in B square minus 4AC, you will get negative 4Y square. Okay, so you determine, okay, what is the value for Y? Okay, let's say if Y greater than 0, just let Y equal to 1. Okay, Y is any number that greater than 0. And then substitute 1 in this value, in this Y. You substitute 1, you will get negative 4. Negative 4 is less than 0. So when Y greater than 0, then the equation is elliptic. The type of this equation depends on value of Y. This Y. If Y equal to 0, if Y here equal to 0, then the equation is parabolic. If Y less than 0, okay, let's say you put Y equal to negative 1, okay, substitute in the equation. Okay, then you get negative 4, which is less than 0. Okay, the equation is elliptic. So when Y greater than 0 and less than 0, the equation is elliptic. Hence, you can write the solution like this. Okay, when Y equal to 0, the equation is parabolic. And then when Y is not equal to 0, then the equation is elliptic. Okay, next we move to second part, which is finite difference method. Okay, finite difference method is one of the simplest, oldest numerical methods to solve, okay, to approximately solve PDE. Okay, sebab apa kita kata approximately? Okay, because this is numerical method. So you can get just approximate value only. Okay, these are the basic steps for FDM. Okay, later I will just call finite difference method as FDM. Okay, basically it's that we divide the solution, okay, into grid of nodes. Okay, we discretizing the domain. Okay, the solution here, we transform into grid of nodes. And then second step, we approximate the differential equation, okay, and the boundary condition by a set of linear algebraic equation or finite difference approximation within the solution region. Okay, later I will show you. And then solve the equation. Let's get discrete grid points. We start with So this is the starting point, where the position of this point is ij. The next point will be I plus 1j. Okay, just this I is changed, okay? I become I plus 1. Okay, j remain. J change when you move up. So here I plus 1j. For this point, I minus 1j. Okay, for this point, 1 is remain because 1 is the value of x. So just j become j plus 1. Here, I remain, j become j minus 1. Okay, here. Okay, x remain, so I plus 1 remain. Same with this point, I plus 1. J become j plus 1. Here, j minus 1. Okay, and this point, I minus 1 remain. This is I minus 1. J become j plus 1. And here, j minus 1. Okay, so for this grid point, okay, the difference between two here, change of x, okay, equal to h. Okay, difference between 2x, the step size. And this one is for okay, k, okay, the difference of t. Okay, let's look at how to solve parabolic problem, okay, using finite difference method. We have many types of equation for parabolic. Okay, here example of PDE. So parabolic equation, the example is heat equation. For hyperbolic, we have wave equation. And for elliptic, we have Laplace equation and also Poisson equation. So we solve a parabolic problem, okay, particularly for heat equation. Okay, these are the definition of one-dimensional heat equation. Okay, persamaan haba in one-dimensional, and is given by this equation. Ut equal to alpha uxx. This is the equation for heat. Okay, where this u. Okay, this one can be write like this. Okay, this u here, u that we want to determine is the temperature at position x and time t. And alpha here is the thermal diffusivity. Okay, for this heat equation, we have value for x here. X is from 0 to L. Okay, and value of t. T is from 0 to infinity. Okay, so this one, okay, this is the boundary condition. Condition at boundary. So here condition when x equal to 0 here. When x equal to 0, the temperature is 0. When x equal to L, the temperature is also 0. And given the initial condition, so the initial temperature is given by this equation. So this is the initial condition, the suhu awal. Okay, the first step is to write the heat equation in the form of finite difference approximation. Okay, this one. Tadi remember, okay, FDM involve finite difference approximation. Okay, given by this formula, finite difference approximation. Okay, this equation is derived from forward difference formula that you have learned before. Okay, forward difference formula. So where this K is the difference of T, H is the difference of X. Okay, we want to find this UIT plus 1. You must rearrange this equation So that we want to find u I t plus 1 equal to, okay, apa? Okay, this is the first step. You just substitute value of k, value of alpha, and also value of h here. And then you rearrange. So that we can find this u I t plus 1. Okay, next, we form the grid cell based on value of x and also value of t given in the question. Okay, after you point the grid, okay, nanti kita tengok contoh. Okay, this is the grid points. Okay, after you point the grids, then you determine the end point. Okay, this end point. Okay, the start, also the end point. Okay, by using this end point is from the boundary condition. Okay, so basically, we want to determine the temperature at each point. Okay, this is the solution for this equation. Okay, finite difference method give the solution in the form of grid point. First, we determine the yellow points. Okay, next, we determine the green point here. We determine the green point by using this formula. Okay, this condition. U x0 Vx. And then the green point from the initial temperature. Okay, next, the red point you determine using equation or formula u I t plus 1 that you determine in step 1 here. Okay, that's why we determine u I t plus 1. Okay, because we want to determine this red points here. So complete. This is the solution for finite difference method. So look at the example. Okay, given an initial value problem for the heat equation. Okay, this equation. This is the heat equation. Okay, with this condition. Okay, given ut equal to uxx here from the question, where alpha equal to 1. This alpha. Okay, the first step is we want to find this u I t plus 1. Okay, remember, we want to determine the red points using this formula. First, you must determine k, value of k, value of alpha, and also value of h. So from the question, alpha equal to 1, k is the difference of t. This is k. And this one is h. So k equal to 0.01, h equal to 0.4. Okay, after you determine value of alpha, k and h, substitute in this formula. Okay, so you must rearrange the equation, the formula, so that this become u I t plus 1. K to the right side first, not this one. This one is minus u I t equal to, so 0.01 divide by 0.4 square and the rest is salin balik ni. Then you will get 0.0625 multiply with this one. U I minus 1 T minus, okay, darab dengan 2. You will get minus 0.125 U I T plus 0.0625 U ui plus 1 t. So ui t plus 1 equal to, and then this ui t you bring to the right side. And then you plus here, plus ui plus 1. So look at here, we have ui plus 1 and ui plus 1 here. So negative 0.125 plus 1. You will get 0.0625 ui minus 1 t, okay, plus 0.875. Okay, this is 0.875 ui plus 0.0625 ui plus 1 t. So this is the equation or the formula for ui t plus 1. Okay, we move to second step, which is we want to form the grid cells. Okay, this is important. Okay, first, you look at the question. X is from 0 to 2. Okay, first you must determine value of X. Okay, but we want to do the grid points. Start with X equal to 0. X equal to 0. And then we move with H equal to 0.4. So the next X will be 0 plus 0.4. Plus 0.4 is 0.8. 1.2. 1.6. And then 2. Okay, next. Okay, we determine the next level of the grid point. Okay, the question asks you to find, okay, solve the heat equation up to T equal to 0.01. So remember our T X or K equal to 0.01. So we just want this, okay, these values only. So if the question said that, okay, solve the question up to 0.02. So you will have extra level here. So you must determine all these points, all the values for this point. But for this question, okay, the question want you to solve up to 0.01 only. So that's it. This is our points that we want to solve. Okay, and then you put the point of view. Here is U00. We start with U00. And then next is U10, U20, U30, U40, and U50. Okay, just value of X is changed. Okay, next, determine for the next level, which is here U01. Here is U11, U21, 31, 41, U51. Okay, you can see here, here is 0, 0. So bila next level, 0 is same and 0 become 1. Same with this point. 1, 1, 0 become 1. Okay, so then we start to determine the values of each point. Remember, we start with the end points. This is the end points by using the boundary conditions. So our boundary conditions, 0t equal to 0, u 2t equal to 0. So hence, u00 equal to 0, equal to 0. So the end point equal to 0. So that the temperature here equal to 0. So in exam, you can write here or, okay, you boleh tulis dalam ni. Or you can write properly like this. U00. Okay, next, we determine the value here. Kat bawah ni. Okay, using the initial condition. U x0 equal to 3x 2 minus x. So the temperature follow this function. So we determine this point first. Here x equal to 0.4. So the temperature is U I0 equal to, and follow this formula. 3 x is 0.4. 2 minus 0.4 equal to 1.92. So the temperature here equal to 1.92. Okay, next, when x equal to 0.8, here, we want to determine temperature U20. So 3, 0.8, 2 minus 0.8 equal to 2.88. So this is the temperature at this point. So the last step is to find this point. U11 until U41. So we use the formula that you have calculated here. You must be very careful when you calculate the value for U I T plus 1. So we want to determine U11. U11 equal to, okay, we want to determine value of U11 here. Okay, you will use these 3 points. Okay, this point. Okay, these 3 points. So Ui minus 1t is refer to this point. Uit is this point. And Ui plus 1t equal to this point. So basically, you will just substitute in this value. Okay, so to determine U11, you will use this value, this 3 value. So to determine U21, you will use these 3 value. So U31, you will use this 3. And so on. So that's why I suggest after you calculate the values here, you substitute the values in the points. So you can see when you calculate the red points. This is the red point. U11 equal to 0.0625 multiply with the first point is 0. Okay, the temperature. Okay, plus 0.875 multiply with the second temperature, which is 1.92. Okay, plus 0.0625 multiply the third point, which is 2.88 equal to, okay, when you calculate, you will get 1.86. So the temperature is 1.86. U21 621. 625 multiply with 421. You will use this 3. So 1.92 plus 2.88 plus 2.88 and 2.88 will become 2.76. So the temperature here is 2.76. Okay, next for U31, okay, you will use just 3 points. So the temperature of U31 is 2.82 and U41 is 1.86. So we have determined all the temperature for each point. So that's it for finite difference method. Okay, to solve heat equation. Okay, we want to solve heat equation by using finite difference method.